Hey Hans, happy Friday. I was going to shoot you this email, but it was getting quite long and detailed, so I figured I'd create a little video and then just kind of walk you through my thoughts and go from there. Okay. Um, First of all, thank you for connecting me with Karen Randall yesterday. She called me and told me about her computer science programming that she's starting. I think that's great. I think that is super exciting for the district and the students. I mean, we both wish that we had something like that when we were in high school, and I think it's a real game changer. Um, I do have been thinking about big data's relationship to computer science, and I'd like to propose something and then get your thoughts on it. Okay. So I think building a program around big data has some clear advantages over computer science. I got to be honest, I'm not 100% familiar with the details of what a computer science curriculum looks like. I have some kind of high level understanding, and I think that a big data program has a number of advantages that I want to lay out to you right now um, in terms of programming. Okay, so for one, uh, big data involves computer programming at its highest levels. So computer science is built into big data. I was just reflecting on all of the computer programming languages that I used in the last year alone, and this is the list I came up with. It's all the heavy hitters: Python, Java, JavaScript, SQL, uh, visualbasics.net. Oftentimes, I'm writing these, I'll be writing in one. So, like today, I was writing in VBA, and I had to make a SQL reference as a database programming. The day before that, I had to use VBA to get data out of a HTML table. Um, and so I had to use table HTML table language, and I mean the list just goes on and on. Uh, so I also want you to imagine uh, the computer science involved in like big data at its best or at its highest level, right? Building artificial intelligence, that's machine learning, and then having those machines and all of our devices communicate with each other. That's the Internet of Things. Imagine the computer science involved in that big data project. you know, Back to advantages. Big data easily ties together all subject areas in really rich ways. Um, so let's look at some examples of that. So, for instance, social studies. I mean, just imagine having students like use some data analytic skills to study census data and find meaningful trends. Science students getting their hands on huge data sets around climate and geology. Understanding the chemistry involved in RAM memory. I mean that's like electricity and all sorts of chemistry and material science. Engineering, learning how to build sensors to collect data, that's huge. Big data is about collecting data, and often that involves sensors. So, how do we do that? Well, that's engineering. Mathematics, that's statistics. English, creating like taking a bunch of data, finding trends, and then being able to effectively communicate complex messages. That's English right there. Um, Art, creating data visualizations, even Jim gathering and analyzing health data. So I know when I was teaching, they had the nutrition diary. Well, wonder if we created dashboards out of that and had students create dashboards out of that, so their information is super visual and almost automated. I don't know about music. I'll have to talk with a musician about that, but I don't know how big data falls into music. That was a funny one to me. And you know what? back to the idea that it ties all subjects together. Imagine that so many teachers can use to learn and teach data analytics in their classroom. Many teachers can learn data analytics, the basics at least, and then teach that in their classroom. So for instance, pivot tables alone, most teachers do not know what a pivot table is. Teaching teachers about pivot tables and then having them teach their students about pivot tables, I mean, that'll just change the game. Uh, so that's a huge advantage. Computer science, I'm not so sure. When you say that to a teacher, they freak out just like they do for mathematics. They don't think they can code. That's what they think it is. Big data, now we can hit all teachers with this. Okay, so big data has many entry points. So I put together a flow of the categories involved with big data. You got data collection. We got to collect the data. If it's already existing, go collect it. And if it isn't existing, figure out how to collect it. Okay, we got all this data. Now we need to combine it. So how are we going to do that? That's tricky. I mean, this is the field that I'm in right here. Uh, we, I mean, that involves just a bunch of different computer programming languages, computer science, taking like written information or not digital information, so analog information, and turning it to digital, and then being able to store things like written messages as data points. That's combining data, and that's really important. My company right now is creating a data lake. So we're trying to pull together all data from everywhere that in our company and then put it into a data lake by joining it and cleaning it in different ways and then automating that whole process. It's brilliant. We got to learn how to store data. This is a big deal. Storing data involves database management, it involves security, it involves like encryption and the material sciences of storing more and more data on smaller and smaller places and science and then we got to learn how to analyze data. This is important. This is like learning all sorts of different software programs, uh, and then learning how to sort, filter, chop up, summarize, uh, and do statistics on data. Then we find meaningful trends in relationships, and now we got to provide compelling visualizations and messaging of those trends and relationships we found here. Then we need to teach computers how to do all of this on their own. So we don't need to do it. That's automation, that's machine learning. Then we need to have all those devices communicate with each other. That's Internet of Things. So, man, there are so many entry points here for students to dig into and be specialized in or show interest in or have success in. It's not all computer programming, which I'm afraid a lot of computer science is. There's so much stuff involved here that students can get hooked on. Big data allows us to work on real life design challenges and questions. And companies are excited to work with us and give us real problems with real data sets. I'm in early conversations with some management from Fitbit, and they're really excited about working with us. But there's all sorts of other data sources out there that students that can solve real problems. Like we can look at census data, we can look at aggregate social media data, and just chop it up and see trends in relationships and meaningful trends in relationships. And big data is unique right now. You know, it sounds like a lot of schools are starting computer science programs, and again, that's great. No knocking it. I love it. But St. Paul will literally be one of the first school districts to start a big data program. And I've talked to think tanks, big data think tanks, who are kind of studying the rollout of big data in public education, and it's not far yet. They've had a couple little pilot classes in, I think, Nevada, but nothing substantial. This would be a big marketing draw for St. Paul Public Schools. And based on everything we've talked about up here, not just marketing, but real life benefits that can have tangible kind of value add for students career wise, intellectually, and just kind of learning how to live and base their decisions on data. That's it's really powerful. So that's where I'm at right now. I just want to say it again. Like I think building a program around big data and having computer science embedded into that has a lot of advantages to it. And I'll stop there, and I'm excited to hear your reflection